Hello again. We are finishing our discussion of linear inequalities, and we're going to talk about how to graph them when they've got x's and y's in them. So we're going to need the xy plane this time, not just the number line. But let's review how we solved inequalities on the number line. Let's go through the steps and go through an example. So first, what I would do, once I have solved an inequality that involves the number line, I find that boundary number, that number that is in the inequality, by switching the inequality sign to an equal sign. I kind of do that mentally. I didn't actually do that. I'm just looking for the number that's in that inequality. Then I have to determine whether I need a hollow dot or a solid dot. If the inequality has a less than or a greater than sign, I'm going to need a hollow dot. Otherwise, I'm going to need a solid dot if it's less than or equal to, or greater than or equal to. Then I decide whether to draw the arrow to the left or to the right of that. And I just kind of use mental math to do that, or I can actually pick numbers on either side of that number that was in the inequality to see where the arrow needs to go. So for example, if I have x is less than -2, I need to find x equals -2 on the number line. And then I look at the inequality. It's got a less than sign, not a less than or equal to, so I'm going to use a hollow dot for that. And I can pick numbers on either side of -2 to see which way to draw the arrow. So if I pick -4 on the left and I pick 0 on the right of -2, -4 actually works because it is less than -2, but 0 isn't. So I need to draw the arrow so that it goes through -4 and doesn't go through 0. Okay? So I'm going through those mental steps because when I'm graphing things on the xy plane, it's very, very similar. A lot of the stuff we did with mental math when we were talking about inequalities on the number line, but I'm actually going to have to do them and actually think about them, write them down when I'm doing xy plane inequalities. So the first thing I'm going to do is I'm going to find, so these were the steps for what I just talked about. They're on the left here. I'm going to talk about how we graph on the xy plane. So instead of finding a boundary point, I'm going to find a boundary line. And so that's the first step. Then if the inequality has a less than or greater than, instead of drawing a hollow dot, I'm going to draw a dotted line through that boundary line. And if it's a less than or equal to or greater than or equal to, I'm going to use a solid line instead, where I would have used a solid dot for number line inequalities. And then, instead of deciding which side the arrow is going to be on, whether it's going to the left or to the right, I have to decide which side of the boundary line to shade, and I'm going to use test points to do this. Okay. Best way to do this is with an example. So let's do 5x minus 4y is less than 20. Well, the first thing I need to do is figure out where that boundary line goes. That boundary line is at 5x minus 4y equals 20. Okay, so to find the x-intercept, remember I cover up the y's and I solve for x. So that would give me 5x equals 20, so x would equal 4. The x-intercept is at 4. If I want to figure out the y-intercept, I cover up the x's. And if I do that, I get -4y equals 20, so y would be -5. So that's where the y-intercept is. I now have 2 points, so I know exactly where the line goes. Okay, but since the inequality is a less than sign, not less than or equal to, I'm going to draw a dotted line through both of those points. Now I need to figure out which side to shade. Am I going to shade above the line or below the line? So I'm going to choose a point that one of them is above the line and one of them is below the line, and I'm going to plug those coordinates into the original inequality to see which one gives me a true statement. One of those points will give me a true statement, one of them will give me a false statement, and I will shade on the side that has the true statement. So if I plug in, I chose 0, 0, and 6, 0. If I plug in 0, 0, I get 5 times 0 minus 4 times 0 is less than 20. Well, that's 0 minus 0. 0 minus 0 is less than 20, so that statement is true. But just to be sure, let's plug in 6, 0. 5 times 6 minus 4 times 0. Well, that's 30 minus 0, which is 30. 30 is not less than 20. That statement is false. So I need to shade the area of the xy plane that has 0, 0, but does not have 6, 0 on it. So I will shade that side. All right, and that's how it works. Here's another example. If I have y is greater than or equal to -2x plus 6, Okay, I need to figure out where the boundary line is, so I change that inequality sign to an equal sign. Okay, the y-intercept is 6. This is in slope-intercept form, so the y-intercept is 6. The slope is -2, so if I rise -2 and I run 1, I get another point that's on the line. I now have 2 points that are on the line. The inequality is a greater than or equal to, so I draw a solid line because it's got that extra line at the bottom of the inequality. And now I need to figure out whether to shade above that line or below that line. So I pick 2 random points. And I've decided to use 0, 0 again and 6, 0 again. As long as they're not points that are actually on the line, you're okay. So I plug in 0, 0 for x and y, and I get 0 is greater than or equal to -2 times 0 plus 6. Well, that simplifies to 0 is greater than or equal to 6. That's not true. That's false. And then if I plug in 6, 0, I get 0 is greater than or equal to -2 times 6 plus 6. So 0 is greater than or equal to, that works out to -6. That's true. So I'm going to shade the side that has 6, 0 on it, but not 0, 0. So that's the solution set right there. Okay, so here's a real world example that we can work through. We have Joseph who has $2 to spend on candy. Jawbreakers cost 25 cents and licorice sticks cost 20 cents each. I'm going to shade the area showing how many of each candy he can buy. So X is going to be the Jawbreakers, the number that he buys, and Y is going to be the licorice sticks. Okay? So 25 cents times the number of Jawbreakers plus 20 cents times the number of licorice sticks has to be less than or equal to 200 cents or $2. So there's my inequality right there. First, I need to figure out where that line is. Change the less than or equal to equals. Okay, this is in standard form, so I will find x-intercepts and y-intercepts. If I find the x-intercept, I'm covering up the y, so it reads 25x equals 200, so the x-intercept is 8. To find the y-intercept, I cover up the x's and I get 20 times y equals 200. The y-intercept is 10. So now I have 2 points, I can draw the line. But is it a dotted line or is it a solid line? Well, the inequality is less than or equal to, and because it's or equal to, I draw a solid line. So there's my solid line. I need to decide whether to shade above or below that line. So I'm going to choose 0, 0, and 9, 9. Just some random point that's above and below the line. If I plug in 0, 0, I get 25 times 0 plus 20 times 0 is less than or equal to 200. Well, that's 0 plus 0 less than or equal to 200. That's true. If I plug in 9, 9, I get 25 times 9 plus 20 times 9, which is way over 200. So that's false. So I shade the side that has 0, 0, but doesn't have 9, 9 on it. So basically, Joseph can buy any combination that's within the shaded area. So anything that's in that green area, he can buy that. So pick any x coordinate, any y coordinate that's in the green area, he can buy that many Jawbreakers and licorice sticks. So that is the last lesson in this unit. If you have any questions, please let me know, and I will see you tomorrow.